welcome to Quick Concepts. Today I'm going to talk a little bit, this is for my Advanced Math 1 students, some geometric properties of circles. So first I'm just going to give you some things that some of you may know, some of you may not. This little guy is called a radius. If you cut a circle from there to there, that's called a chord. Some of these you should know. This is a diameter. You've got a line that cuts it at 2 points that doesn't go through the center. It's called a secant. And then if you have a point that runs through just the edge of the circle, which essentially makes a perpendicular line with like the radius, this is called a tangent line, or it's tangent to the circle. So secant touches at 2 points, a tangent touches at 1. Hopefully you know half of a circle is a semicircle, and that this is 180 degrees. A whole circle measures 360 degrees. Then you have what's called major arcs and minor arcs. So a major arc is going to take up more than half of a circle. So this would be a major arc. And then a minor arc would take up less than half the circle. This is called a minor arc. And then, of course, if it was perfectly 180 like this would be a semicircular arc. Okay, any arc of a central angle equals the central angle. So if this is a 30 degrees, this is 30 degrees. So that's for the measure of an arc there. If you have an inscribed angle, so this is a central angle. If you have an inscribed angle, meaning it's like from here to here, it's always half. So let's say this is 40, this would be 20. So this is an inscribed angle. It's always half of the arc it makes with the other side. And when you have two lengths cut in a circle like this, and this is XY, this is PQ, essentially this times this is always equal to this times this. And let's see, what are some other ones that you need to know? Oh, this one, these are tangent to. And these were things we touched on in Algebra 2. So these will be equal. So this would be x plus y. This is x plus y. And this is g. And this is g. So these things are equal. If you have a circle and you have an exterior, and this is y and this is z, z minus y divided by 2 is always x. And then if you have one that's like this, so this would be, let's call this x. These are both x, right, because they're equal. And this is y and z. This would be y plus z divided by 2 is x. I think that's it. Yeah, that pretty much covers it. Let's do a couple of the problems that are going to kind of have you going with this. So let's do just a couple examples. So let's say we have something like this. And this is 54 degrees. This is 38 degrees. And this is y plus 13 degrees. And this is x plus 16 degrees. And they want us to find x and y. So first of all, I want you to understand that these two are equal. And the reason they're equal is if you look, this is an inscribed angle, so this is 108, because it's double that. And this is an inscribed angle. See how they're equal? So we can say x plus 16 is equal to 54 degrees. So x is going to be, what is 54 minus 16? That's 38. And the same thing with the y. So here we can see that this is an inscribed angle. So this is going to be equal to that. So we can say y plus 13 is equal to 38. Subtract 13 from both sides. I swear that's a 13. This is 38. Man, I am just doing great today. This is 25 degrees. So that's that one. And then let's say you have a problem that looks like this. So 24, this is 12. So remember, these are multiplied together. So we'd say x plus 5 times 24 is equal to x plus 15 times 12. So 24x plus 120 is equal to 12x plus, no idea what that is, 12 times 15. So if I subtract 12x from both sides, I get 12x, and then I subtract 120 from both sides. So x is 5. And we'll do one more just to kind of cement a couple of these things home. So x plus 3 equals 7, so x is equal to 4. X plus y equals 19. 4 plus y equals 19, so y is equal to 15. And of course we know these are equal. So that pretty much covers properties of circles.